Okay, now the really fun part. Let's think about how we're going to convert those amazing questions that we just came up with into some best practice SQL, which is a little bit more rigid than just asking these questions kind of willy-nilly. All right, so first thing, as we mentioned previously, you want to enable that standard SQL as part of your code. Again, it's faster, it's more standards compliant, and if you need a reference in case you've inherited old code that was written in legacy SQL, there's that reference available to you there, which also includes a migration for which functions now have these new names in standard SQL. And an additional key point that we want to highlight is when you're running multiple queries, or say you have a long script because you're just exploring and you want to keep everything all within one document, you can highlight a portion of your code and then execute selected or run selected on just that piece by clicking on that down arrow and then running that selected. Another key difference, and then this is what you need to keep in mind when you're pulling data from one of these tables, is you need to escape the table name. And what that means is you need to actually enclose not just the table name, but all the prefixes is where it comes from, right? So your table is stored within a data set, like the IRS 990 data set, and then stored within a project. In this particular case, the public BigQuery project. So you need to actually have project.dataset.table. So a common error here is, say, just having just the table. So if you had just the table, BigQuery wouldn't know which table is part of which data set. Maybe 20 people that are taking this class already just created a table with that name. Whose project am I querying from? Because you can actually query data across multiple people's projects. So of course, naturally you want to actually get to some table that can actually be resolved to a specific BigQuery table in the back end. All right, so let's take a look at this query. So this query says, give me, select means give me the columns that follow the select statement. In this particular case, tot revenue or total revenue. Give me the total revenue from this particular data set. Okay, so keep in mind what we're actually going to be returning here. So total revenue, that's not going to be the total revenue for all the filings in 2015. Total revenue is a field. So in actuality, what you're going to get back is you're going to get back just the total revenue for every single one of those records. You know, a million of the filings for 2015. Okay, so maybe we can limit the results to 10 so we're not just returning a bunch of data that we have to paginate our way through. But is this useful, especially if we have just the column for total revenue? Not really. I mean, you can see you can get a general feel that there's a lot of potentially non-zero revenue there, but we don't know who it's from. And I mean, in this particular case, it's not even ordered either. So maybe we could potentially add an order by clause. All right, now we're getting somewhere, right? So now we have revenue, total revenue for 2015 filings for those exemption filings. Now we're going to order it, and we're going to order it from highest to lowest. And we do that by adding that order by clause near the end, second to last in the query. And we're sorting it from highest to lowest, and how you actually denote that in SQL is descending, or DESC is one of the parameters for that value there. It defaults, the order by clause defaults to ascending, or ASC, which would be the opposite. And it works the same way with alphabetically, A to Z or Z to A. Okay, so a key point here is whenever you're ordering something, especially if you have more than 50 rows, make sure you limit it because there's no reason to return back all of that data in those paginated results. You're just wasting your bytes processed or your amount of data that you're consuming.